So today we're gonna focus on SBC LTR data, particularly on the visualization. And there's a few things I'd like to talk through. Is the three major topics. One is the SBC time series data figure. So we do have those data figure online. So for example, if you just come into SBC, you want to explore, I want to understand in general what the data looks like over the past 20 plus years. And you can go ahead and click open all those figures, and then you will know, oh, temperature, this is how it goes, or oxygen over the past this many years, how they go. And I can show you those on the website. And we update those figures whenever we have a new set of data ready. So if you see the figure sitting there and then it's not updated, means the sensor may be still out somewhere in the ocean. It hasn't come back yet. So, and then Darren is the one update most of the figures. So you can shoot him an email, say, hey, Darren, can we update the figures? The second one is the R script used to generate those time series figures. So I post those on the GitHub account. So if you see one of the time series figures, you say, this look awesome, we want to get this published in my manuscript. You can go ahead and grab that figure code and anything. So you can reproduce or change the font size or change the color, whatever you want to do on the R script to reproduce that figure to use in your manuscript. The coolest one, I think, is the help from the ChatGPT and Copilot. I will get more in that. And that, if you guys want to know more in depth, I will show you like how I do that in my R environment. Okay, so let's take a look at the time series figure. Okay, so if you get into the SBC website, and under the data tab, and you will see that the time series data visualization. So if you click open that, those are the time series figure. We have about 30 plus big time series data set, but not all of them here. Because those are like the major ones. I feel like students over the years have been sending emails asking me, how do you think about this? And then, how do we look at this data set? So it's like the most important part of those time series data. So I only plot those, not every single ones. And so in this, you can see a few categories. So the annual kelp forest community dynamic, which is the survey we done once a year around July, August, and then look at the organisms in the water in the benthic environment. We also have a kelp net primary production, and that is, we have a kelp survey every month, and then look at it every month, how they change from month to month. We have some key species, mainly is ocean and lobster. We have a beach habitat, mostly is the beach consumers, the shorebirds, and the rat pile on the beach. And we have a whole series of ocean environmental conditions, like the temperature, oxygen, pH from different sites. And so if you just like click open any of those figures, it will show you, okay, those are the general trends. You can see some seasonal trends, you can see some long-term trends, and at a different site. And so, for example, you say, oh, I only, in my publication, there's only 2 of the sites. I don't need all those in there. So the next step would be go grab the GitHub account article to reproduce this figure with only the 2 sites that you want, and then generate it. So now let's go to the GitHub account to see how those being generated. So I'm logging into my account. But if you, from your account, you pretty much search this SBC data visualization. It's a little bit dim. Okay, if you search that, you could probably locate that GitHub account. Can you guys do that? Try that. If you can locate it, that'd be good. If not, then probably have to search my name. It's LKUIUCSB.
Your name.
Okay, if you click into,
Yeah.
okay, good. Okay, perfect. So when you click into it, this is the repository. And so I want to show you how to use those codes. And those are existing codes that I programmed with Darren's help. And we put together this all the material in this GitHub account. And so there are two main files, the two main R scripts in here. One is called read SBC data.r. This is a function. This is you don't run that code independently. This is a function that when you say I want to read this particular data set, you give it a name, and then you will go grab these functions and go onto the EDI repository. If you come in last week, you will know this amount of data initiated. This is the data repository, all the SBC LTR data located. So you go to the repository, download the data. So it takes about, say, depending on how big the data are, take probably about 20 seconds to a minute to download data before running all the code. And this gives you a chance that every time when we update the data will automatically go into a repository. So every time we download it, it's the newest version of that data set. So this is convenient. So you never need to log into the SBC server to take a look. Oh, where's the data? Can we have the newest data? You don't even know that. You don't even need to do that anymore. You can just run that code. That's the latest SBC data set. And the one that I call the figure long-term studies, those are the R squared. And I want to show you guys about some structures in there. So make your data making process easier. So if you want to follow the steps, you can go ahead and click the code and you can download the code in the zip and then unzip it. But I already downloaded myself. So I'm gonna directly open it here. So those are the three files in there, a function R and the R squared that we can run. And this is the CSV that include all the time series figure names on there. So if you go on the SBC data catalog, as I showed you guys last week, you may see some names like this, like giant count MPP. You may see some like benchmark water sample pH for field calibration. You may see those names. And then you're like, okay, I want to download that data set. How do I do it? You come in as the SBC and then open this CSV and copy that name. This is the full name of that data set. And then put in the R code that I'm going to show you guys soon. And you can download that data set and exactly that data set. So this is just to give you a list that what we have in this code to handle about 54 data sets. Okay, so we open this.
What is identifier and entity?
Good question. Okay, so in here, there's a identifier. This is the identifier particular unique number in the repository. So if you open a repository, let's say, you actually don't have to really know that part for this particular purpose. But this is an identifier that every time when we publish a new data set, they've been assigned to this particular data package. And this identifier is unique to that package. So every time when we update, say, okay, next version coming in October, in December, it still keep this one. The identifier still keep the same number. So this number almost equal and unique to this particular data set. It's never gonna change in that repository. But this is called, oh yeah, this is entity order. So in some of the data package, there are more than one. There are more than one CSV file. So we will have some of them, like this one probably has 6 in there. So that's why it has 1, 2, 3, 4, 5, 6. And this particular data package. So they have particular order. And this order doesn't change either. So this is just those identifier and entity order is just to help the code to identify. I want the sys or I want the first CSV in that data package. So it's an index used in the R code that in the background, you probably don't even look at it. So let's look. Okay, this is the figure. So this is the R script. And so some general structure here. So the first, I typically remove everything in the space in case you have something running before you open this. And this whole code is to tell the computer that I want to put the work directory at current, whatever this code currently exists. And loading some R packages and source that function. So every time I know to get that function running when I need to read the data package. And this is the drive. If you have other drives that other than this current drive, you can define it if you need to. Otherwise, don't even bother to change anything. And this is the line site. This is the figure function that I made it here. And because all the figure looks quite similar, they have x-axis always daytime, and y-axis some sort of variable. And so I make a function to do that instead of have to code this function 20 something times. So this is a function inside of our script. So every time when you run anything, for sure you run this part because you want to set out a basic environment for this particular code. And then after that, everything below that will be depends on which figure you want. You can choose the section you want to run. And so generally it give it a name. So the first one is a lobster abundance data set. And then it did some data manipulation about the data before we plot it. For example, taking the average of the site across site. And then it start plot. And then it say the plot out at the current location, whatever you specified to. And that's the first trunk is for lobster. And second trunk is for annual reef biomass. So this is the same. It re-end the biomass of this data set, the entire name I copied from the CSV file. And it do some data manipulation. This one's a little bit more complicated because I want to filter out some of the species because just that some species really occupy a lot of biomass. So I just want to ignore those species and look at the rest of it. So, and then do the plotting using the same function, but assign different variables to that function and then save it out. So these are the similar to like fish density, biomass for all species before the filter. This is a cal MPP. So everything below that is the same structure. So if you have a particular figure, you want to plot it, go ahead and find the name. Or you don't even have to find the exact name because if you scroll down this script, very likely that name makes sense, that which figure you want. And so you can take a look or do a keyword search within the code, say locate locate the names and the figure, you can generate it. So we can run one example. We can run one example here. How about just a lobster data set, which is slightly easier. Okay, so first it did some downloading, and then it load the data, and then manipulate the data, then it plot this. And this one should look just exactly the same as the one we posted online. Okay, so just to orient a few of you coming slightly later, so we look at the time series figures on the SBC website, and we went to the GitHub account, my GitHub account, and there is a repository called SBC Data Visualization. which is the R script that help to produce everything you see on the SBC website about SBC long-term time series data. So if you need to rerun any of the code to reproduce a figure or only subset of the data, then you can do this. So because a few students say, hey, we need some time series figure for the pH data, for the temperature data. How do we do that? And then say, okay, let's look at this code. And this is the figure. You can produce it. You can even truncate it. You can filter out, let's say, I'm interested in 2014 to 2016. You can filter to keep that particular time span and then make the figure the same. So this is how it works. Okay, any questions before I move next step?
Just a technical, the first function you use, the RM list equals the list. What is that for again?
Oh, that's for erase out all the R environment. Like for example, all this, like that just in case you ran some other R codes before and then a whole bunch of variables in the R environment that's stored there. I don't want the R to confuse with the previous one in case they have some conflict or anything. So it just writes everything before that.
So it's like clicking on the room there.
Yeah, so if we run, it will clean out that everything on the right panel there. So if we run that one line to clean out everything and start over. And so this article has been helping so far. I know it's about like 4 or 5 graduate students to produce their time series figure. And it's just an easy, quick way for them to do their homework. Okay, so that's that part. Those are all the technical parts. Now I want to introduce a very cool tool that I like. Okay, let's see. The Copilot. This is your AI program. So Copilot, this is a program that the GitHub decided to help us because everybody posts their codes on GitHub, and sometimes the code doesn't have a good description, and so it's hard for people to understand the code, and sometimes take the coder a longer time to figure out the syntax part. For example, you say, oh, I want to take the average across site. Okay, what's the syntax? I know you have to group by and something, and you have to have a summarize, or is it filter or slice? So you might have a question about that specific syntax, even this is not what I want to get it done. So this is a program that you can just tell R saying, okay, I want to do the averaging, and R will help you pop out the whole function. And so you don't even have to remember syntax. But if you say, okay, I'm brand new to R, I have no idea about R, I just install a blank R Studio, I never even look at the R code, I tell you this tool will not help, because this tool can potentially produce something very bad. And then if you don't know R at all, you just by solely rely on this code, I would say, no. You want to have some understanding on the code and to know, oh, I think I want this code get down this way, and this sentence on the code looks good. So you have to have a good understanding on the R structure to make it work the way you want it. Okay, so some example here. Okay, we open the R Studio. Let's open a blank one and say, okay, so I was thinking to use the lobster data set as an example too. Okay, so let's plot a lobster and a similar figure like this. How do we do that? First, as I said, we don't need to go download the data anymore these days. We can just go on the SBC website and go find the data catalog, and I just need to locate the lobster data set. Okay, I normally search keyword lobster. Okay, lobster abundance size of fishing pressure. Let's go that one. And then remember, here's a package origin. That's take you to the EDI. So I can get the R script to download this particular data package. Okay, so I don't do this part because if I download this part, it has about this many KBs in my storage, which I don't really need it. And when I share the code with a collaborator, I want to just share the code so they can go download it themselves. This is small, this lobster data set, but some of our data set like 10 gigabyte. You don't want to send to your collaborator 10 gigabyte in your Gmail because they're gonna eat out everything. So now going to R, I want to go into the R script to download it. And now I need to do is go copy this whole thing. And then paste, copy and paste in my R environment. This is called data download. See, in this data download, it has a few things at the end showing a summary, which I don't really need it, but you can keep it if you want, but I don't really need it. So I delete all this until here. I keep everything else in there. This is the data download patch. Oh, hold on. This is download 2 of them. Okay, now I only need the first one. I only need the first one. Yeah, this is the first one. So there's a second data set in the same package, which you don't need it. It's a coordinated data set. Okay. So this is data download. We can run it. Let's say highlight, run. Okay, take only about 2 seconds downloading, fine. And this is a part started Copilot. So how do I want this go? First, this is the first download, and then they have a variable called DT1. First, I want to assign this to another variable in case that I break that DT1. I don't want to have to go back and download again. So I will say pound sign, and I will say assign to different, assign to, let's say, df variable. So you see, I didn't type anything, and I should zoom in this. Let's do that. Okay, let me zoom in this so you can see it better. Let me go down a few lines so you can see it here. So when I type in just a demonstration here saying assign to df variable, and I click enter, and I haven't typed anything. So Copilot, based on what you type in the comment, the pound sign, after that pound sign, we show you, okay, this is what you want to get done. It's assign a new variable. Sure, yes, I want that. So I click tab, and I accept Copilot's suggestion. And then next one, what do I want to do? I read in a data set and I take a look. Okay, this data set has a year, month, day, site, transact, replicate. Okay, that means there'll be multiple lobsters show up in one replicate with different size. Now I don't care about size. I don't want to know the total count for that replicate. Okay, so I tell pound sign here, and then I tell the R code saying, sum up the count for each replicate. And then I stop there, and then it do this part. Say, okay, this is great. There's no problem, but I want it in a more tidier format. So I don't want this format. So I start typing something. df1, I want to assign it to a new one. And then df, because this is a variable. And this one pop up. So it automatically pop up this, showing you, this is how you should supposed to sum up this. Okay, so I resource a year, month, day, site, transact, site. No, I don't really want size because I don't care the size of the lobster. So I just want to, let's click, and then I click tab to assign it first, but I don't care about size. So I go in to remove this part. because I only care how many of them in one transact, not stack and replicate. See, this is the part that if you have no idea about our code, you get stuck here because it's like, oh no, what's happening? Why doesn't make the one I wanted? This is the part that if you have some sense about our code, you say, oh no, this is a lot closer, at least the syntax wise, the structure wise, use the group by, use summarize, this is right, use ungroup, this is all right. But the specific variable is not exactly the one I want. So you go in and change a little bit, say, okay, good. And okay, so next one, even tell you that if even automatically generate that, if count is 0, you should assign the NA. No, we never want to do that. Okay, we don't want to assign the random NA in the data set. So that's not what we want. It just generated based on what, like when they run the AI training, it's a lot of people do this step, but that's not the step I want. So next one, I make a pound sign. I want, let's say, average across site, average count across site. Okay, I click enter. Okay, group by all this. It only followed the original ones. Okay, what did it do? Count equal to min count. Okay, what next? Okay, sure, but I want it across site. So I don't really care about the transact level. Oh no, see, at this part, I feel like, no, I need to calculate the density before I do that. So I go back to a step. I should ask it, so calculate the density. Okay, so it tell me is to calculate the density, I need to do is mutate. And then it even give you an equation. I look at it, fine, this is exactly the equation I want. And so this is become average density across site. So it's not average to count anymore because I want the density of the lobster. Okay, so I revise the comment and I go back there. So at this part, it's not that smart. It thinks that I still want, it thinks that I want the average density, but it still give me a transact in the code, which I don't want it. Okay, so I accept mostly because most of the syntax are right, but I just don't want a transact in there because I want to add the site level. Okay, so we don't need to carry density anymore. Okay, so we have this. We have the data set ready at the, let's delete that side. We have the density ready here to calculate at the site over time. And next one, what do we want to? We want to do the ggplot. So we want to say plot density over time. It's thinking. Okay, it jump out of ggplot. Everything in there. Is it right? I'm not sure. Let's run it. Take a look. So to plot this figure, technically take about 5 minutes including coding. So if you interested in doing any kind of time series figure, Copilot can help you to that point, and it can help you with some of the syntax, but you still have to a little bit more knowledgeable than just like no idea about R code. So because this is R code, okay, now let's see, what else do we want to do with that? Let's say, even give me a very good labels too. Okay, what about if I want, now we already have a legend, so we don't need to add a legend. We can do a white background. Okay, add that. So let's rerun this ggplot. Oh, yes, it is white. Let's see. Let's see, remove the grid line. Okay, you can make a guess that what I really want when I say white background. I want to remove the grid line. Yeah, it's white. Yes. Okay, it's smart enough. Remove the grid line, sure. Okay, let's try out this part. Okay, let's rerun it. Okay, now remove it. And then so if you need to change anything, what about if I want like faucet, I want to break into multiple panels. Okay, I want to do some faucet on here by site. Okay, it pop up. So all I need to do is accept the suggestions and run it again. Okay, it break into multiple panels. So especially for some of you that you start learning R, you know there's a ggplot you want to plot, you know some structures, and this will help you that you don't have to keep going back to the Google engine to search, how do I do this part, and read through all the all people's poster and then see, oh, this is how we handle it. So this is to help you to speed up. Of course, something may not work. You go delete it and tell the ads and comments that are more specific. Some of them may not help, like, because maybe the way I say it, it's too short, the sentence, it doesn't get it yet. So you can add some sentence and we might pop out something else. So that is this one. And okay, I was even explore something cool. Okay. What about, I want to get, yes.
Is Copilot good for plotting all types of plots, or specifically for, is it better for certain types of plots, or does it give you advice on everything?
No, you have to know what plot you want. For example, right now, this is pretty much like, because it's through AI training. So a lot of people plot this point plus line plot. And this is what most of the people plot. But if you say, I want, let's say, I want a histogram. Let's say, plot histogram. Let's see what it pop up. Okay, let's see. That's a rough histogram. And then next is that you probably go in and change in how you want to plot it. For example, the bin size and all that to make the histogram cooler. But you can tell the Copilot, say, this is exactly what I want. So can you generate a code for it? Yeah, yes.
Have you run into this, just that if you give it a prompt that it doesn't understand, will it give you a message that says like, I don't know what you want, or will it always try to generate something for you?
Sometimes it doesn't know, it doesn't do anything.
It just
So
leaves it blank.
it will leave a blank, doesn't do anything. See, no completion available.
Okay.
So when you type in something, you have no idea. It's like, for example, I want to run a time series analysis. This maybe he knows, but some other ones I did have experience. So I tried a couple of times. It doesn't do anything. It just leaves that line there.
Okay,
Because I think it runs through the database. It just nothing get trained before in their system. So they don't know what exactly it is. Especially those new analysis method that, oh, people say, like, we want to use the SEM model, like structure equation models like that. Is that it hasn't have enough database for it to train that AI yet. So it may give you, most likely probably not gonna give you something, but if we start has more and more training, it start giving you something.
Okay.
And then you can explore it from there. And that part, for that particular analysis, I probably don't rely on this. That's the part I move to the ChatGPT.
okay,
Because that's the times like that particular analysis, I'm really interested in know if there's any one or two cases. Have you ever seen those? This is like by training, like 80%, 90% people. But for like, if there's a case for that, I would go into the ChatGPT. So if anybody ever put in an R script about that and a ChatGPT have been gone into their database as a storage source, then they will pop that out for you. So this is how people get down in their database. and then they even help you do some summary about that. Have you guys ever done a ChatGPT? I know you do.
Yeah.
Okay, so that's a case, that specific case for some high level analysis.
Okay.
I would go into ChatGPT, even in the same time to do some research. Is this the best way to do that particular analysis? Yeah. Yes.
I might miss this in the beginning, but is the Copilot monthly fee or as students do we get it free?
Good question. I believe that it's okay. Say it this way. For us, it's a monthly fee. There is a monthly fee, $10.
Yeah.
I think for everybody, universal. But for the lab, you could ask to get reimbursement for that. As a lab, you could ask. I'm not sure how the advisor respond to that, but you definitely could ask. Because if this is gonna help you with your graduate study, I believe that your advisor will probably be happy to support that. And so they can, like, for example, as a researcher, sometimes we need to purchase a software. And we will ask, and then we're gonna get the software reimbursement after we pay for it out of pocket. So you can consider us and then see if this is being part of the grant can cover it. Yeah, it'd be easier. Unfortunately, they don't have a share license like some other software like MATLAB. And they like SAS, they will have a share license. They have one and you can share about 3 or 4 people. Unless you have a like GitHub enterprise. Otherwise, if your personal account, it's typically just go, you probably pay for it and then get reimbursement. Yeah. Any other question? I think this is really cool. I saw this about 2 months ago. I was like, this really saved my time because even sometimes I know Oracle can get this part down, but I don't know that what's the actual syntax to go or what's the actual function. So I just right now, it used to be, I have to go into Google to search, okay, how do you get this down? And then saw a few examples. Oh, this is maybe how to get it down. So I put it in. But this is, you tell the Copilot to say, I want to get it down in this way. And then it will pop up and it can help you. Yep. And so the other thing I was thinking, there is a cool thing here. Okay, analysis, right? We're not going through a very complicated analysis. We just want some simple linear regression. Can you do that? Okay. Linear regression for density over time. Okay. I think it calculated me. No, that's not what I want. Something it didn't understand this part. Okay. Let's see. How can I do it better? Say, does he know this? Okay, this is a lot better. So it is something, it doesn't understand what I said. And then so it pop up with this one. Okay, even suggest you, see, I stop here, suggest you. You don't really need an LN function. You can use ANOVA, sure. Try it, run ANOVA.
Really?
So-
wrong.
Let's see what I actually run here. Okay, so it show you, well, first you know to run the linear regression and then show you ANOVA to see the p-value, but you don't really need ANOVA for that. You can just output that one. Oh, sometimes I use the summary. And this is most of the time I use it. Okay, so what else? What about, can it do this? I'm curious. What about if I run? control for year. Because sometimes we want to compare within a year. Okay. It actually gives you exactly the mixed model with the year as a control. Okay, because to do that, we have to load the library. We have to say to load the library. Otherwise, you can't do that part. See, it knows to load this LME4.
It's not smart enough to load it though for you beforehand.
Oh,
Here's a function, find the library.
yeah, see, if I don't have a R background or understanding, I would say, okay, you just run that code. But if I just run that code without load library, it's just not gonna run. So because I know that function, if you need load that function, you need to go load the library. So I told it to load library, but I forgot which library exactly need to run that, and then so it load the library that I want. Okay. Anything else you guys want to try?
Make a shiny app.
Okay, look. That case, we have to have a new one. Okay, here we go. Make a shiny app to plot figures. It doesn't have. It said no. Okay. And this part is not smart. What about if I continue this? Because we have data loaded. Okay. Okay, tell you to load the shiny first. And then you stop there. No, actually, it should be smarter than that because I did try the shiny app before, but not in the R student environment. Okay, now it remind me something I can show you guys is it's not. Okay, say it this way. When I start exercising this, I was actually exercising using it to make the shiny app, but today it doesn't pop up here because the Copilot for our studio is still in development. So it's not like as good as the other software yet. So when I have to use the Copilot for the R script, and typically I go into another software called VS Code. And that's the code understand more about the Copilot. So we can exercise that using my remote computer just to show you guys. Okay, this is let's see if I launch this. It's in my remote computer in the office. So this is the VS Code that I use. I use in a variety of the coding, not just R, including the other like MATLAB code. Okay, we're gonna start a new file. And I want this to be an R file. Okay. And then now we started. Press Control I. Let me zoom a little bit. Too bad you guys can't see it. I think it's a little bit too big. Let's see. How should I? Okay. It's not that I have good view about it. Anybody know how to make it larger?
Command plus.
Control plus.
Command. Well, she's on a Windows in this one.
Yeah, it's let's see.
There's a view tab also that might have it.
Okay, let me have to exit this. Okay, maybe we start from here. Let's see. It automatically shrink. Okay, see if we can make this work. Okay. Make it slightly larger. Okay. Okay, see here. A Shiny app to display the result of analysis after, I don't care about after what, I just care about, can you make this Shiny app here? Library, Shiny. Is up there too? Interesting. How about let me get this going before the view starts. Oh. Okay. Same UI. Is it now what it produce? Okay, good. Server. Okay, good. Shiny app. Okay, so I have those. And I can copy that over. See, this is the code that generated in the VS Code environment. And I copy that over so you guys can see this better outside the remote desktop. Let's start a new one. Okay, let's run this. Here we go. It has you can add more requirements. Like I need a tab, I need a left-hand tab, I need a top tab column. You can add those and we'll start building all those tabs for you. So that's a pretty cool. So even build your Shiny app.
And is there
Yes.
an option to, let's say you get tired of receiving all these suggestions and you wanna make it harder for yourself, how do you deactivate the suggestions?
Oh, you mean deactivate the whole Copilot thing or just
Is there a way to like tell him like stop making suggestions now, like mode, and then go back to suggestion mode? Is that possible?
in the VS Code, the software I make, on the bottom right-hand side, not this one, on the bottom right-hand side, there's a button called a Copilot. And then you can just disable it when you code. This one, I haven't exercised this one yet, but I'm sure they could, because they should, I haven't looked into that yet. But they could, because in all the software, this is just an add-on, so you can stop the add-on whenever you feel like, yeah. And then they'll never make you any suggestions until it's out, this is the time. Okay, any questions? Okay, I hope this tool help you explore your data. Okay, thank you for coming today. And we will have a data publication workshop on the November 17th. And that's the one, if you guys have data about to get published, yes, definitely come, and then we can even work on your data right after the workshop and then get it published as soon as possible. Yes,
Thank you so much.
Thank you.
thank you.